thanks for all joining the Tech Talk. My name is David Cutright, one of the wireless instructors at Sunset. Little background, before Sunset, I worked for a company called GigaWave. We did nothing but Cisco wireless. I worked for them last 15 years. October last year, my boss sold the company, so I'm now part of Sunset. So got 15 years as far as Cisco wireless. And then, prior to that, I kind of did the network security administrator job. And prior to that, I had 20 years in the Marine Corps. I retired 2002. I worked on air traffic control systems. So I had a strong RF background. And I actually got into wireless because I was renewing a routing and switching cert and kind of got hooked because to me, it's a radio. So kind of new to Sunset, and they started doing these, telling me about the Tech Talk. So in the shoot for this first wireless one. So we kind of decide what to talk about. And, the thing about wireless that nowadays, right, everybody's working from home. So I thought, maybe some things to cover and look at things as far as looking at your home wireless. So did any of you have background or experience with wireless at all?
Very limited.
Yeah. So where are most of you at? Where are you at, Steve?
Honestly, I don't work with wireless much at all, but I thought this topic was interesting because I'd love to optimize my home Wi-Fi because I seem to have continual issues.
What do you have for wireless? You have did you buy a box or you got the service provider's box?
I have the service provider's box, which I bought from them and actually upgraded. And then I had a friend of mine who works for one of the local channel partners come in and install some Cisco access points upstairs and down. But once I upgraded my home wireless router there, it's weird because now I have two SSIDs, and actually I have three now that I think about it. So the old one never deactivated, and then I have a 5G and a regular SSID, and it just seems to be all over the place. So
are these standalone access points?
Yeah.
Okay. What models do you know?
They're older Cisco. I'm not sure exactly. They're older Cisco models, so I know that.
So you still running them then?
Yep.
So you got those going into a switch, I guess, and a firewall in your house?
Nope.
No. Okay. I have a lot of experience with autonomous stuff, so we can take a look at some of your settings, and I'll go over. When we talk about other things, I'll try to show you things. I don't have access to an autonomous though, but I'll try to show you things you may want to look at on your access points in there. But where are most of you guys located? Where are you physically located at, Steve?
I'm in Denver.
Oh, okay. Are most of you in the Colorado, Denver area?
California.
California? Okay. So I just want to give you a heads up. I'm located just north of San Antonio, and we just got hit with a snow blizzard. I call it a blizzard here because they're not used to it here. I grew up north, and their power grid can't handle this, and a lot of their power has been down across the state, and they've been doing these rolling power outages. And so if I go offline, just know that that's probably what happened. So I've been without water since Sunday. So that's why I don't have my video on. I haven't been able to shave. I haven't been able to do anything. So all my pipes are frozen. So it's been an adventure. And then we're supposed to get hit again tonight. So like I said, I got a lot of experience in the wireless. So feel free to stop, ask questions. I just kind of, we do a CCNA type wireless, a basic wireless course. There's actually two versions. There's one that Cisco does. There's another vendor neutral called CWMP folks, and they do a CWNA, which really gets in depth. So I've kind of taken stuff from both those courses and generalized in a PowerPoint and kind of going over different topics and try to relate to it as far as, home and think about it in your home network. Now, so I'll go over some of the different standards and terminologies that you may have heard. We'll focus on RSSI and SNR, which again, for the most part, probably at home, it's stuff that you don't look at. Maybe you don't even know or aware about what it is and how it pertains to you. We'll go over frequencies and channels, which to me, that's the biggest problem in your home network, because we use 2.4 and a 5 gig, and the problem with the 2.4, which we'll discuss, we have limited amount of channels, but a lot of these home, I should say local ISP provided boxes, they come up, and what they do is they scan all the channels and they find the less busiest one. So, yours may come up and be channel 2, the neighbors may come up and be channel 3, and another one may be channel 4, and it's a mess, particularly on the 2.4 you'll see. And I'll tell you different free tools that you can use to look at these different things and what's happening to your network. Now, what kind of control do you have over your wireless? That may be, I don't know if you have access to your boxes and what you can do. Some don't. Some, again, depending on the vendors, you have limited configuration options, right? It just kind of does this out of the box thing. So you may not have a lot of granular control, but I certainly can, we can go over different things, and maybe you can set and things to look at. And so I run, again, having been Cisco, we wrote a lot of labs for Cisco certification. So I've always had access to equipment. So all the spare equipment, I actually run a Cisco wireless LAN controller with 3 APs in my home network, which is overkill for most people. I also, because of the other stuff that I do, I have an Aruba network set up in my house too, to kind of show when I do these different classes of comparison. I don't really use the Aruba one a lot, but again, I can show you different settings on there depending on what you have. And again, feel free to pop in. You can type in chats or just ask a question, ask away. One of the things, I said, doing wireless or an instructor for the last 15 years, I had a tour as an instructor in the Marine Corps as well. And, it's easier when you're in the Marine Corps because you have a captive audience. And so when I got into IT and going to training, I kind of drives me crazy because I got some guy up there reading a PowerPoint to me. And so it used to drive me crazy. So when I was an instructor, I always look at instructing as more of me helping somebody do their job, not me up there lecturing. So the more interaction, the better. I don't like to do death by PowerPoint. So, but again, most of us I take it, most of you work from home now. Do any of you have to go into work, or do most of you work from home?
I still have to go in.
Do you, like on a regular basis?
So often. I work for the county out here in County of San Bernardino. So
Okay.
we manage the phone systems and all kinds of other stuff. So yeah, every so often we have to go in the office still, and once a week, every 5 weeks, I'm on call. So we have to take care of the help desk in the we man the tech desk, what they call the tech desk. So we get all the nice tickets to come in and fix things.
So do you do, I take it, do all networking? So wireless is part of your job too?
Yeah, as of right now, we're currently upgrading the regional hospital that's out here. So basically, I work most of the time. I work from home for 9 hours, and then I'll travel to the hospital. And we're currently upgrading all the cabling and running on an Aruba system for their wireless networks out there for the COVID tents that they're putting outside. And so it's just been constant for about 2 years now.
Wow. So I take it that's more portable stuff for the tents.
Yeah, pretty much. So they're setting up these tent cities out here, which never got used, but they're just wasting money and putting up all these brand new wireless access points everywhere, using the opportunity to do it.
Yeah. Yeah, we won't get into that discussion then, right?
Right.
Yeah. So, and the thing about wireless and terminologies, and, so much of it to me is sales pitch, and that goes for home and it goes for the enterprise as well. And, with COVID, I said most of us working from home now, you're now how many, with Zooms and Skypes and all that, we're doing more bandwidth attentive. And, some people are really into that. They got to buy the newest thing coming out. And so some people spend a lot of money on new technology coming out, and then, you know, their connections are bad, or, you know, they always want to, of course, everybody blames it on the other person too, but a lot of times it's just your environment. So, I mean, you know, it's not like the wired where we can plug into a gig port and we know we got that. And the wireless, there's so many variables of the speed that you connect at. And for the most part, to me, even though wireless pays my bills, I would rather be wired. Um, when I lived in Florida, I transplanted to Texas in 2006, and I bought a new house. And my wife was going to kill me if I ran wiring, so I did wireless. But honest, I would rather do wireless, be wired. My son lives in San Antonio. They got gig fiber to the house. I mean, if you're running gig fiber to your home, why do you want to be wireless when you got a, you know, it's a bottleneck in there? So we kind of go over some different things in performance and things like that. So part of the Wi-Fi standard 802.11, the IEEE, I should say, basically covers two standards: 802.11, which is your wireless standards, and 802.3, which is your wired side. Now, 802.11 is the wireless standard, and then you have the amendments under that. So that's A through, we're already through the alphabet twice now on there. And we're just kind of going over ones that particularly associated to your home network. And again, you can apply this in an enterprise environment too. So the original standard was this 802.11, 1997, as you can see in here. And it was developed to operate in the 2.4 frequency. So again, backstep a little bit. If you're not familiar, you know, our two main frequencies are 2.4 and 5 gig, but it's actually part of what they call an ISM, Industrial Scientific Medical Band. There used to be 900 megahertz way back when I first got into it, we were doing 900 megahertz. If somebody old enough to remember, we had 900 megahertz cordless phones, you know, that was an unlicensed frequency. So pretty much 2.4 and 5 gig are our two main frequencies. Now moving forward, you're going to start seeing stuff in the 6 gig range. So there's new stuff coming out as well. But the early adoption was 802.11 was 2.4 as part of this ISM. And it really was about being connected. So they were low speeds, low data rates. We're talking 1 to 2 meg speeds is all that was. Now, eventually, the IEEE comes out with the amendments, and was actually ratified first was 802.11a. And 802.11a used the 5 gig. But for whatever reason, what got into our devices back then was 802.11b, which is what they call Wi-Fi 1. But if you look in the letter-wise, A came first. And I don't know if it was power related, because, you know, the one thing about frequencies and propagation is 2.4 goes better. It goes out better than 5 gig. You got longer distances. So I think a lot of the design back then was 2.4. I remember getting into doing wireless initially. There was no 5 gig radios in the laptop. There was no 5 gig radios in most of your access points. So 802.11a came out, but what was in our laptop was this 802.11b. Sometimes, again, they change terminologies, and what you're going to hear them now reference is they call it Wi-Fi 1, Wi-Fi 2, Wi-Fi 3. For me, I look at wireless has 2.4 or 5 gig, and I just know that we have 802.11a is 5 gig. I know that 802.11n is 5 gig. I know that 802.11ac is 5 gig, and I know AX is 5 gig. And that's how I just look at it, as 5 gig and 2.4. But you'll see different terminologies in there, and a lot of it is for sales. So now they changed it again, and now it's Wi-Fi 1, Wi-Fi 2. So you may see that sometimes when you're buying, you know, stuff for home in a box or something like that. So if you notice, again, 802.11b was actually got what out first. And I remember somebody at work had a laptop that did that 5 gig, and the access point that I was using was an old Cisco one, and they only did 2.4, and it had a PCMI slot in it. You bought a 5 gig radio card to slide in there. And so I picked one up off eBay, and we're like doing 5 gig, and me and this other guy were the only laptops 5 gig. We're like, this is cool. Look at these speeds, you know, because your speeds on the B only went up to 11 meg, and the 5 gig with 802.11a went up to 54 meg of speeds in there. So, and initially it used a different modulation type, which we'll talk about, which what they call OFDM. So the modulation gave you that increased speed. So 802.11b was the older data rates, which were 5.5 and 11 meg data rates. So it's slower speeds. So eventually what gets ratified is 802.11g. I think a lot of people that were doing 2.4 are like, hey, I want to be fast. So G uses 2.4. It uses the same modulation technique that the A used. And so you get the same speeds, but it was backward compatible with the B at 2.4 in there. Eventually, it gets ratified, and this is probably one of the drastic changes, is 802.11n, or what they call Wi-Fi 4. And N improves speeds tremendously. I mean, again, our top speeds were up to 54 meg, and it's based on what they call single in, single out stream. So you transmit, receive, transmit, receive. N comes out, and they introduce a new technology called MIMO or MIMO. So now you have multiple input, multiple output. So these access points have radio chains in them. So you have multiple transmitters, multiple receivers, and you can do multiple streams. So your access points now, have 3 transmit, 3 receivers. If your device has 3 transmit, 3 receivers and can support 3 spatial streams, we're tripling the speeds. So, and if you don't, if you still have legacy stuff, your access points still have 3 transmitters. I'll still transmit you 3 signals. It just means you're going to have a better signal quality. So that was a big jump in 2009 with 802.11n, and it was 2.4 and 5 gig, and it's all backward compatible in there. Now, eventually in 2013, they come out with this IEEE 802.11ac, what they call Wi-Fi 5. Now, AC expanded on what N already did. So the only thing is it improves speeds through other methods where making things just simple as making it more efficient. That's all you need to look at. It was really N technology, but we're more efficient. So now the claim on when AC came out, they had what they called Wave 1 and Wave 2. Wave 1 went to 1.3 gig speeds. Wave 2 claim is 6.7 gig speeds. And I say claim because, again, just this is what we're talking about in that opening slide is why spend all this money on the technology? And again, in the sales hype, oh, Wave 2, we can do 6 point whatever gig speeds. Well, that's if your access points support that and your clients support that. Most of your devices that you support probably at home and at work, mobile devices. And whether it's an iPad, an iPhone, an Android tablet, what have you, most of them can only do 1 or 2 spatial streams. You're not going to see those speeds. So that's why I say don't get caught up in that hype. And, and then still the limiting factor is a lot of people spend this money. I remember particularly when AC came out. And the other thing you want to pay attention to, because this new standard was Wi-Fi 6 down here, this AX. When you buy stuff, and I'll show you how you can do this, is you want to make sure it's certified. So this is all part of what they call the Wi-Fi Alliance. It's a certification for these standards. These vendors certify their equipment, but a lot of those vendors to get stuff out to the market sell it as 802.11ax compatible, which means it's not going to do everything that the AC comes. So I always want to make sure that when you're buying stuff, even for home, is you want it certified, not compatible in there. So when AC came out, I said there was a Wave 1, Wave 2. And if you're not looking at the fine print, oh, look, my wireless router does AC. I'm supposed to do 6 gig. No, you're Wave 1. You can't. You can do 1.3. So that's, kind of reading between the lines on there. So eventually, nowadays, just recently in the last couple of years, this AX or Wi-Fi 6 comes out. Now, Wi-Fi 6 really changes things. So up till then, this, again, how we talk, how we transmit, we're taking our information, right? We're putting it onto a carrier. How we do that is these various modulation techniques. So they all use what they call OFDM up till this Wi-Fi 6 came out. And it has little sub carriers that it's transmitting out to give you these speeds in there. But it's, I talk to you, I'm done. I talk to the next guy, I'm done. I talk to this guy, I'm done. I can only talk to one person at a time, and we're all standing in line waiting our turn. Well, AX, one of the big things that's introduced in there is a new modulation, what they call OFDMA. So your channels are basically 20 megahertz wide channels. So you have one 20 megahertz wide channel that you use. Now, you have the capability to bond those channels. You can make wider channels. That, again, gives you more speed. But what OFDM does is, think about it as taking that 20 megahertz, and now let's say I break it to two 10 megahertz channels, and I could talk to two people at a time. So it breaks the channel down and into sub channels, so to speak, and it can talk to multiple clients at a time. So up to this point, if you're into routing and switching, and you can remember back in the hub days, years and years ago, your access point is a wireless hub. It's a big giant collision avoidance network. So with this Wi-Fi 6, we're getting closer to being a wireless switch, in my opinion, in there. So the other thing that they introduced, it's starting to come out now. You won't, I've got friends of mine that deploy this stuff, and they're starting to play with it already, is what they call Wi-Fi 6E. E is an echo, which now uses 6 gig frequencies. Now, this 6 gig band, you're going to have more channels, which we'll talk about later, and you're really going to open up things in there. And then a lot of the things about with this Wi-Fi 6 is Internet of Things devices. So, these Internet of Thing devices, they don't need a whole lot of bandwidth. And that's the advantage of, I'm wasting bandwidth just to send data. It's like, you're at the airport picking up the rent-a-car bus. It goes around. It doesn't matter if you're the only one on there. It just keeps going around. So, it can hold 100 people, but it doesn't matter. Whereas the Wi-Fi 6 kind of, let's fill the bus up and get it around in there. So the 6E is going to be really drastic. Now, will you see it anytime soon? It's out. It's already out there. You can buy access points, but just remember that when again, jumping on new technology, particularly at home, is you got to look at it, do your devices support that, right? Does your iPhones, your Android, whatever you're using at home, does it support that? And I'm sure most of you at home, if you're like me, you have a bunch of devices, whether it's security cameras, wireless cameras, echoes and echo dots and all that kind of stuff in your home. Those right now aren't going to support those. So that's going to be the limiting factor in there. So wireless as a medium, it is half duplex. So meaning you transmit or receive. And it is a radio function. We talked about, mentioned a little Stevie got, 3 SSIDs or WLANs. It's still a radio function. It doesn't matter how many you have. It's still a per radio thing. So, in a design wise, you're better off with one, or 2 SSIDs and not one of that. And that's just because your access points beacon that information out, and it causes channel utilization to go up. So again, a good analogy is you can think about communication in the wireless. It literally is like talking on a walkie-talkie. It's like doing a meeting. Now, do most of you do a lot of Zoom meetings at work?
Constantly.
Like, how many people are in your Zoom meetings?
Depends. If it's a full company meeting, I mean, it can be 40 or 50.
Right. So 40 or 50 in those meetings, and somebody asks a question, right? Now everybody tries to talk at the same time. And that's literally what happens in your wireless. It's like a big giant Zoom meeting. So you have what they call listen before you talk. Now, the old method is what they call the distributed coordinated function. So again, think about talking on a walkie-talkie or in a Zoom meeting. Somebody kind of has to control, right, who gets to talk. So in a walkie-talkie, if I'm talking, right, and I say, hey, what time do you want to go to lunch today? Over. When I select over, it indicates I'm done talking, right? So everybody gets to respond, but who gets to talk is whoever clicks that button first. So what the mechanism does is, instead of just clicking on the microphone and start talking, you pick a random number. So think about, everybody picks a random number. And when I say over, you start counting down. Now you can only count down if nobody else is talking. And they use what they call a carrier sense. It's energy. So they just listen to the physical energy to detect if somebody's talking or not. They also use what they call a virtual carrier sense. So when somebody is talking, they send out what they call a nav field. It tells all of us how long you're going to talk. So that's the thing about this listen before you talk network, the communication is that you got to make sure that everybody can hear you, so they need to know to shut up while you're talking. And that's the hardest problem, not so much at home, probably more in an enterprise, because it's like going to a movie and you're trying to watch the movie, right? And then all those side conversations going on, and you're trying, dude, I'm trying to watch this movie, right? So that's what's going on. And we have all those other interferes that input that, but it's just a big giant pick a number countdown. When you get to 0, it's your turn to talk. When you send, we all supposed to shut up. And so you got to make sure everybody hears you and know that. It is, again, an unlicensed band. Now the 900 megahertz used, they brought it back. There's actually a new standard now that uses 900 megahertz. I think they're trying to use it for more Internet of Things devices. I just never seen it deployed. 2.45 gig, again, soon on the 6 gig. It's pretty close to being here now. So now the signal's going in so far, right? Inverse square law. Just think about throwing a rock into a pond. So again, think of where your wireless router or access point is at home, and think of that as throwing a rock into a pond. Now you throw the rock in the pond, the wave goes out. As the wave goes out, it spreads out, right? As it spreads out, it gets weaker and weaker, spreads out farther and farther and weaker. How far does it go? Well, what's in your home? What's that wall doing to that signal as it goes out, right? So different material affects your signal in different ways, and it knocks the amplitude down or the power. So you have weaker and weaker and weaker signals in there. And, when they talk about being a shared spectrum, it is because it's an unlicensed band. And particularly, again, at home, you got everything from baby monitors, maybe you've got game controllers, you got microwaves, Bluetooth devices. There's a lot of stuff in that 2-point frequency, not so much in the 5 gig. So in relationship to your access point and your clients, you've got power settings. So just like the wattage on a hair dryer or a generator, right, is we have power that goes out of the access point. And depending, again, on the vendor, right, they have transmit power that goes out. Your device is the receiver at that point. Now, this is another thing, as different vendors, your devices have different receive sensitivity. That receive sensitivity means is what's the weakest signal that it can still understand and demodulate that signal. And the problem nowadays is our radios have gotten better and better. They're better listeners. Unfortunately, because they hear better, then that actually causes problems as well. So think about, you're like Superman and you're going to the movie and you hear literally every conversation going on in that movie theater, right? And that's that receive sensitivity on there. Now, what we use to measure, or kind of an idea of how strong our signal is, what they call receive signal strength indicator. It's just a measurement how well your device can hear that signal from your wireless router, your access point. And again, it's one of the problems people complain about is it's not a standard. And so what I mean is some vendors, their signal strength can mean something different. Now they're all generally pretty close. The only one I've ever had an issue with way back when I used to do a lot of voice over wireless with Cisco phones, and these older phones, their RSSI value is like a 10, 20, 30, whatever. Now, most of the time, signal strength, you can see this little slide here, right? It's a negative dB value. So most of your measurements are generally in milliwatts or decibels. The decibel is just comparison of milliwatts. And the reason they do that is because if you did milliwatts and you wanted signal strength, it would be like 0.0000001. Hey, what's your RSSI? Oh, it's 0.0000001. So instead they use what they call a decibel, and a decibel is just a comparison. Decibels actually start out on telephones of how much loss over a copper wire. So in this little meter, then the graph, it's pretty close. What's a good signal strength for you? Typically what I try to do when I used to do a lot of design, my magic number was -65 signal strength. And then the other big one that you want to pay attention to is what they call signal-noise ratio. So you have a noise floor, which where's the noise come from? Well, your noise comes from other access points. It comes from those interferes. Typically negative 90 and up. So negative 90 to negative 100 is, I wouldn't say, let's say a good level of noise. Your signal strength, again, a good signal strength, I would say negative 50 to negative 60s, somewhere in there. And the signal noise ratio is just calculated as you just take your signal strength minus your noise floor. So if my noise is negative 100 and my signal strength is negative 70, the difference is 30. So that would be a 30 dB signal noise ratio. So a good indicator is roughly negative 65 with 25 dB signal noise ratio. That's what you kind of want everywhere in your network. Now, the problem is, how do you know what it is? Because, what do you have in your windows? If you look at Windows, right, what does it tell you? Well, I got 4 bars here. What's that in signal strength? And it doesn't, a lot of the vendors don't tell you signal noise ratio. And this we'll go over in the tools part of this. I'll show you some different things that you can look at to get that information out of your device. So to me, I look at RSSI and SNR in there. Now, frequency is just the number, it's measured in hertz. It's the number of currents in per unit of time. So we're talking about 2.4 and 5 gig. Well, really what's more important is this wavelength. And the wavelength, think of the wavelength as actually, it's electromagnetic wave coming off an antenna. It's the size of the wave. So again, think about the rock in the pond. So you throw the rock in the pond, how many times do you see that wave is the frequency? How big is that wave? Is the wavelength. So roughly on 2.4, it's like 12 centimeters. That's the actual wave. And on 5 gig, it's about 5 centimeters. That's the actual size of the wave. Now, they don't really use the terminologies wavelengths anymore. A lot of ham radio operators, though, they still do. And when radios first came out years and years and years ago, it was tune into the 2 meter. It wasn't, hey, turn into 101.1. And so there was a lot of, they kind of changed terminologies to reference channels and frequencies versus wavelengths. But they're more or less one and the same. If you know frequency, you can calculate wavelength. If you know wavelength, you can calculate the frequency. But this is a great slide to show you. This is the frequency range, right? And so you can see we're going everything from, audio range to the left to gamma on the right. So the lower the frequency is, the bigger the wavelength and the farther it goes. That's why 2.4 signal goes out better than a 5 gig. It's a bigger wavelength. Now, if you look at the lower spectrum, and where it's showing you your wavelength is the size of a building. So when I was in the Marine Corps, I spent about 5 or 6 years in Hawaii. This is in the early 80s. There was it's still there. They just don't let you go up anymore, but they had a maintenance site. It was called Stairway to Heaven. And what it was actually an antenna that was draped over the side of these mountains there, that they had a stairs going up for the maintenance on that thing. So It was huge, and they used it to talk to submarines in World War II. It was ultra low. I mean, the wavelength was almost a mile. It was crazy. So, but again, we fall into roughly 2.45 gig. I said 12 centimeters, 5 or 6 centimeters. So the lower the frequency, the bigger the wavelength. And again, another way to look at it is if you ever been at a stoplight, right? Somebody's got their stereo cranked up in their car and it's a mile away. And what's the first thing you hear? You can hear that bass, right? It's because the bass is a lower frequency. It carries farther in there. Now your channels, this is the other thing is channel usage. Now on 2.4, notice they're showing you 3 channels. The 2.4 is actually made up of 11 channels. But when they went to the FCC asking for these channels as part of the 802.11, they said, hey, we want 11 channels. Okay, here you go. What they didn't ask for is we want non-overlapping channels. So what they're showing you here is 1, 6, and 11 are what they call 3 non-overlapping channels. So they're spaced out so that you're not touching each other, so to speak, right? The 5 gig, you have the capability of doing up to 25 channels. Now, this is the important part. Again, I'll show you this when we get into the tools, but I'll show you real quick. This is a my Cisco controller in my network in my house. But I just want to show you a couple things real quick that you may or may not have the option to configure on your home wireless routers, but this is what you want to look at. So this thing has radio management built in, but you generally have some kind of settings here. So here I have what they call dynamic channel assignment. And what I wanted to show you, these are all the available channels. You can see I've got 11 channels, but by default, enterprise stuff only uses those 3, and that's because of those are non-overlapping. The problem in your home is, depending on the vendor, they'll scan 1 through 11 and they find the least busiest channel, and I'll be channel 2. Again, like I was saying before, your neighbors, I'll be channel 3. And if they reboot it for whatever reason, they scan and go, well, I'll be channel 5 now. They don't stay on that channel. If they don't reboot, they'll stay on that channel. They don't move. But on the 5 gig, what you'll notice, again, this depends on the vendor, is you have more channel options. So if I check this box, you see all these available channels. These are what they call non-overlapping channels. So kind of think of it this way. If I had 6 access points in a room, right? And I know we don't have this at home, but if I had 6 access points in a room and I'm doing 2.4, I can only use 1, 6, 11. Then I'm going to have to develop a channel plan so that 1, 6, 11, 1, 6, 11, right? So I'm going to have to reuse those channels and then make sure they're not touching. And in a wireless 5 gig, with 23, 24 channels, I literally could put 24 access points in that same room and they would be all on their own channel because they're all non-overlapping channels. So better design. Again, even at home, I have to turn 2.4 on because I still have some smart TVs that do only 2.4. If any of you are running like some of those older Rokus, they were 2.4 only. But for me, I generally, most everything I have, I do 5 gig only. Got more channels. The other thing you notice how you can go wider channels. I can't do that in a 2.4, except for some home use allows you to do that. And I'll show you that. So you can go wider channels. Just remember, the wider the channel, the less you have. So like mine are set to 40 meg channel. So that means this becomes a channel now. This becomes a channel. So now I have less channels to use, but they're wider, which means I have more speeds. But it still comes down to is, if your clients support that stuff or not. So when you're looking at your home, to me, optimizing that's one thing you want to look at is your channels. So 2.4, only 3 non-overlapping. It says available channels. It's 3 non-overlapping. 5 gig, 25. Or propagates better. Yeah, if I was doing coverage and I wanted to get out to the backyard, sure, 2.4. And my internet connection is going up and down. It says no channel bonding. That's again the problem. The channel bonding is at home. It does let you do it. A lot of vendors, a lot of ISP provided boxes do turn that on. Not to make worse. but shared spectrum, microwave, Bluetooth, games, game controllers, cordless phones, you know, etc. There's more stuff to deal with on the 2.4. It's dirtier air. 5 gig, it says share spectrum with Doppler radars. The only thing that you have to concern yourself with in the 5 gig is that radar, which it's middle channels that some people don't use in there. Amplitude, just think of that as the signal strength or the power of your signal. The modulation is taking our intelligence onto a carrier. So if you look at AM, FM radios, if you got an FM radio station to you listen to, 101.1 or whatever, right? They're taking that music, which is an audio, and they're putting on the carrier, which is an FM. It uses what they call frequency modulation. So it's taking that audio, that music, modulating it onto a carrier, transmits it out. Now you have a receiver in your vehicle, you tune to that, it demodulates the signal, puts it on your speaker, and you hear it. Well, the same process in the Wi-Fi is it's taking your application, your data, and again, I'm not going to get into the OSI model, but it's taking that information and then converting it to ones and zeros to modulate onto a carrier, sending it over a radio, 2.4 or 5 gig. Again, you have a receiver in your mobile device, your laptop, that now demodulates that signal and decodes that information in there. So there are different types of modulation in there. So now, as things have progressed that I was showing you with the IEEE standard, we've got more techniques. So channel bonding, spatial streams, multiple user MIMOs, what they call. So all these are different techniques that were introduced to increase that. And again, it's a good analogy to look at channel bonding as, again, think of it as going from a 1 or 2 lane highway to a 4-way highway. You know, spatial streams is we now have multiple roads that you have options to. So the technology is changing rapidly. It's just, are your clients catching up to it sometime? So what does all that mean? What do I care about RSSI, SNR modulation? So what I want to show you here is, this is an older chart, but this is what they call an MCS table. And I want you to think about, and again, I don't know if you ever look at, you know, the clients and what your speeds you connect at, but think about different speeds that you have that you connect and what determines that. Have here is, these are, each one of these columns here is referencing spatial streams. Now, depending on your access points and your clients, depends on how many spatial streams you got. So here, this chart is showing you 3 spatial streams. So the top tier is 1 spatial stream. Now look at the top, you have channel bonding. You got 20 megahertz, you've got 40 megahertz, you got 8. This is how wide your channels can be. And then if you notice, there's a column here for modulation, right? So for me to talk faster to you, it required you to have a stronger signal, a better RSSI, a better SNR. If you don't have that level, it's going to cause errors, and then it's going to back off. What's it going to do? It's going to talk to you slower. And those are these different modulation speeds. Think of it as it's just talking to you slower. So look at these, for example, we'll look at this one right here, 20 megahertz. This one here, I don't know if my highlighter is showing up well. So 20 megahertz wide channel, which is generally the default, 1 spatial stream, which is generally most of your mobile devices can only do 1 spatial stream. Your fastest speeds are 86.7 meg data rates. And for you to do that, you're going to have a negative 59 signal strength and a 29 dB SNR. Now, you obviously connect faster. Well, most of the devices, if they do 2 spatial streams, you can see we can get 173. If we can do 3 spatial streams, we can get 289, but that's going to require you to have a strong signal. I mean, literally near the access points. So it's a combination of wider channels, better signal quality that lets me talk at these higher data rates. So if you look on this chart, the hot speed down here is 1.3 gig. So to get 1.3 gig speeds, I would have to do 3 spatial streams, 80 megahertz wide channel, and have a negative 51 signal strength with the 37 SNR. So I have, I said my network in my home, I have older 3700 series access points. So I can actually do that. I have an iMac can do 3 spatial streams. I can get 1.3 gig speeds out of an iMac. That's the only thing I have in my house that I can do that. So utilities that you can use to look at your signal strength. Now, any of you Mac users?
Not necessarily, but I have an Airport Extreme.
Yes, I have.
Mac laptops?
Yes.
Do you? I'll show you some cool things on a Mac, but on a Windows real quick, if you go to your Windows and you go to your command line, you have these, I don't know if any of you are familiar with NetSH commands on Windows. So if you do it NetSH wireless LAN, show interface. Now it actually shows you here the SSID that connected to, and you can see the radio type, I'm G, and then you can see I'm not G. I don't know why it says G. It's a bug, but I'm on channel 149, and you can see my transmit receive is I'm doing 866.7 meg data rate, and look at my signal. It says 83%. So that's what's telling you those bars mean. You can actually take the 83%, you subtract 100, divide by 2, and you can actually calculate RSSI off that. So NetSH commands, you can learn a lot on the Windows ones. Now on, this is a screen mirroring utility that I have. So I'm gonna try to connect my iPhone to this. So if you're an iPhone user, if this don't, here we go. Couple utilities that I use, it's kind of handy. Again, you want to verify signal strength and what's going on in your network. On the iPhone, download the Airport utility. It's free. Now, what you have to do is once you download the Airport utility, go into your settings here where your apps are, find the Airport utility. And what you want to do is you want to make sure Wi-Fi scanning is turned on here. Where it says Wi-Fi, make sure that's turned on. So when that's turned on, you can now go to your Airport utility, click Wi-Fi scan, do a scan, and it'll show you what SSIDs are near you and the channel. So you can actually, like I can click on this one here and it gives me the history. So I can see channel 1 and I can see RSSI negative 61, negative 62. So if I know which one I'm connecting to, I can walk around and kind of use that kind of as a poor man site survey tool. Another one, this is okay. When it first came out, this is called AR Wi-Fi. It's an app on the Apple Store. The AR Wi-Fi, when it first came out, was pretty cool. It was like 99 cents. Now they charge you like $4. I don't know necessarily if it's worth that, but I'll show you. This is kind of handy for home. To me, again, when it was like $1.99 or whatever it was worth it. I don't know about $4.99 yet. So you connect to your Wi-Fi, right? And then you click this connect button. And then what it does is it scans. Notice how it actually does a ping test too. So it's showing me latency and things like that. So all I'm really looking at is delay, and you can see I'm actually getting delay on this to my router. So I've been having slow internet connection. Now, once I do that, I keep it going. Now, AR is augmented reality. So now what I do is I use my camera. Now, see how it drops the dots there? And I can walk around. And I'm just doing this area around my desk. I'm not going to get up because I got my headset on. But so you get the idea of how it drops it in there. And then when it actually can show you, it's got a little meter on it. See in the bottom left-hand corner. So it's continuously doing that ping test basically in there. And then you can go back now and you can actually go back and see areas where you maybe have problems in there. So That's a handy little utility. Now, are any of you Android users?
Only.
They got the better utilities.
They have way better utilities.
I know.
I don't like closed software. Open
Well,
source.
yeah, Apple, when they had this same similar utility, and they got all that privacy thing, and soon as I don't why I bought the damn tool, it worked really cool, and then all of a sudden, yeah, it doesn't work anymore. It's called this Wi-Fi map for the Apple. It was a Wi-Fi scanner. Well, the Android version, I'll show you. You can go to this Android. I don't have an Android to demo this, so I'll just show you. I have a video of it. So it's called Wi-Fi AR, and I'll show you what this utility does. So again, it's augmented reality. It's using your camera, and it drops these pins, so you can actually see your signal strength. Now the Apple version, I could just click in my camera, and it would drop the pin for me, and I can actually do a speed test. I think you can on this one. Is you can change the views, and I believe you can click on those little pins that drops, and you can like do a speed test from that thing. So that, yeah, most definitely Android has the better tools. Now,
That was actually cool. What was that called again?
AR Wi-Fi.
AR Wi-Fi.
Here, I'll see. I'm gonna run out of time here. I start going on this thing. Sometimes I go off tangent. Where's the chat at? I popped it in the chat. Now, another tool that's handy that I use a lot is, and you can download it free. You'll have to Google search, but it's called Insider. I don't know if anybody's familiar with this. This is handy to use at home because it shows you what other stuff's out on your networks. So it scans, and then you can see all the SSIDs that are in the environment, right? And then look on the bottom, it actually
Hey, dude, I'm in
look
the
at 2.4, the bottom here. You've got
Tech Talk
1, 6, and 11. Those are actually my access points.
Trey, and then I've got to call Aaron.
But look at, there's somebody that's on like channel 3. There's another one.
Okay.
There's 2 on channel 3 and channel 4. So the way this one's not too bad on this one. Generally, you'll see there's a couple of people in my neighborhood that have channel bonding turned on, and you'll see the 2.4 just looks like just one big mess in here. But you can see how much, look, compared the spectrum, the 5 gig to the 2.4, and you see it's a lot different. Another one that's pretty cool is called NetSpot. NetSpot has a pay version. You can actually use this to do site surveys in it. I don't want to do the survey. So if you notice, it kind of does the same thing, right? Why is this thing stopping? But you can break it out and shows you signal strength. It's the Insider is a little bit better, but this thing does have a survey mode that you can use it in. But one of my favorite tools that I use, and again, I have my older Mac connected to this. I'm going to switch. I'm going to make it the host. I'm going to share. So this one now.
Excuse me, I have a question.
Yeah.
Can you please share these links for these apps? I saw you were showing these notes. Just maybe you can just put in this chat these links.
I didn't understand what you were saying. So
you were showing this notes file with links for these applications. Maybe you can share these on chat. Links for applications.
So some of the other tools, you want links to it?
Yeah.
So here I'm going to do, hold on. When I get done with this, I have a notepad that again, when I teach the CCNA wireless, I share the information, and I'll upload the text file, and it has all the links in it. Okay.
Okay.
So I'm just going to show this one real quick. This one is Apple, and it's called Wi-Fi Explorer. And guy Adrian Granados is develops it. He's got a bunch of other tools now. I think it's like $10 on the Mac store. They make a pro version, which is really cool because I don't know, anybody familiar with like Raspberry Pis, little Linux arms?
Yes.
Well, you can build these, what they call nano Pis, and you can put a wireless card in them and you plug them into the wired network. And with this pro version of this, you can use it as a remote sensor. So I have it set up that way. This one is just the normal version. But what I like about it is you can see on the left compared to the other ones, you can break it down here. And so, okay, I want to look at, 5 gig only, or I want to look at what channels are 80 megahertz. So you can, you have more views of it. Here I can actually look at the different, what devices are out there and who's supporting them. If I just want to look at SSIDs, I can. Now I can click on it. So there's a Netgear out here, for example. I click on the Netgear, you can see it's over here on channel 157, right? So now I can go into the network details. I can say, okay, there's the Netgear, there's the vendor's Netgear, signal strength at 55%, what band they're using, max data rate 1.73, and I can see what channels they're using. So they got channel bonding turned on, and I can see the security settings. So, and I can see signal strength history. Again, I can see where it falls in the spectrum. And then on this one, it's almost like doing a packet capture. And so I can get different information on here. Now, what I generally look at, for example, on the 2.4, so here's, you can see that same Netgear there on the 2.4. But see where it says supported data rates right here? And it says 1, and then it's got a B2. So Bs are what they call basic data rates. And the lower that basic data rate is, the bigger your cell is. So they've got this stuff set to default. And this is another thing, a lot of your home stuff on the 2.4 defaults to 1 meg data rate. The lower that data rate is, the bigger your cell is. The bigger the cell, the more people you have in it, the more it hears, the more interferes, et cetera, et cetera. So you want to control your cell size. You generally want to turn all that lower stuff off. So that's another setting you may or may not have in your network where you control that. And I kind of ran out of time on that.
I have a question. I don't know if this question is part of these Zoom meetings or this topic, but returning back a few moments of the wireless controller, I saw one option that is a channel assignment method, and the interval is 10 minutes. I don't know how, what is the impact from this channel assignment, if it's better to get a long time or a short time.
So mostly I take it doing the next session too.
Oh, okay.
So I'll just move into this. It's a good question because I talk about this a lot of times in my other classes. So by default, this thing is set actually to 10 minutes, which means is the way that the algorithm works is that it calculates and then goes, hey, we need to change the channels. Well, that means by default, your APs can be switching channels every 10 minutes. So yeah, that's bad, because if that AP switch channels every 10 minutes, your clients are dropping off 10 minutes. So with Cisco now I'm talking about, what I generally do is I set mine to 12 or 24 hours. I don't let it change during like working hours. Now, if I set this to 12 hours, and let's say now you have an interfere that's impacting your network, it's going to wait 12 hours to make a channel change. But if you scroll down, I take it you have a Cisco controller?
Yep.
So if you scroll down to the bottom of this, what you want to turn on is what they call event driven. So higher to me is better. So your APs aren't changing channels all the time. And then what this event driven does is it overrides that. So it doesn't matter what this is, 12 or 24 hours. If that interferer impacts your network at a certain level, it makes the channel change in 30 seconds. Now, what you can look at real quick here is if you go to your DCA, look right here. When was the last auto channel assignment? If it says like, 60 seconds ago, like I said, I generally have mine set to 12 or 24. I don't know why mine's set to an hour. This is my home one. That's why. So it hasn't made any channel changes. And that's what you don't want it making channel changes. Does that answer your question?
Yeah, thanks.
Yeah. So if you open up the chats, you guys see the file, it's called tips, and it has all the links, the different tools that I've been kind of sharing. Now, I said this all comes out of, again, if you really want to get more into wireless, the CWNA folks do a great job of theory on the wireless. The Cisco one's not too bad, but there's a wireless fundamental class that they have. Any questions over that topic?